Hello, everybody. I'm Andrew Scopa with Developmentor, and this session is test-driven development using Microsoft Test. I have my email address here if you would like to jot that down, ascopa@develop.com. I won't be taking any questions during this presentation, but feel free to drop me an email. I also have an agenda that we'll be covering in a moment, but I wanted to mention that I have a file that contains a starting point for the demonstration I'll be going through, and it's at this web address here. Now, this web address is case sensitive. It's OneDrive. I'm going to, for those of you that are already in attendance, I'm going to put this in the chat window, so if you can download that at your leisure, and later on at the end of this presentation, PowerPoint presentation, I'll put it out there again. So the goal here is to cover test-driven development, and we're going to start by looking at the fundamentals of how you create your type system. And the goal is to always program or design your application to work at an abstraction layer. In other words, you set up your interfaces and your abstract types, and that way we can set up our what we call test doubles. And it also provides us a means by which we can implement a technique known as dependency injection. Also, somewhat, some people refer to this as inversion of control, but that has a somewhat different meaning. But we'll talk about dependency injection as well. So our goal, again, is to always make sure that when we're designing our system, that we design to an interface, and that's going to help us decouple the code. Not only will it allow our implementation to vary, but it provides a means by which we can use this technique known as dependency injection, where a concrete implementation of our abstraction can be injected usually as a constructor argument, but also as an argument in a method call or as a property setting. And when we create these concrete types, they can represent the real types, or they can represent what are known as test doubles, which are we can think of them as stand-ins for the actual type that provide the same interface, but perform different operations for testing purposes. Now, there are different kinds of test doubles that we can create, and the terminology can be somewhat confusing. So, for example, we have fakes and stubs and spies and mocks. We'll be using Microsoft Test, as I said, and with Microsoft Test, the Premium and Ultimate Edition, they give you a library that we can use that will generate what we call fakes. And through the fakes, we have a means by which we can create our own implementations based on the abstraction through the library. So we're going to just walk through here what the distinction is. So again, the terminology here is sometimes blurred in actual usage. But so fakes are typically referred to as dummies or simplified versions of an abstraction. So this is useful when you have an abstraction, but its behavior is really not of interest. So you see here we have a class called fake logger, and this is going to implement the method set associated with the iLogger contract. And we just stub out the log method that's provided by the iLogger interface. Now, stubs are generated from the interface that are being used inside of the target project, which we call typically the system under test, SUT. So the stub object provides us an implementation of the interface, and this lets us drive conditions test conditions in a variety of different ways. Now, so in our demo, we'll be heavily utilizing this stub implementation for setting up our test-driven development. Now, spies, interestingly enough, are a special type of a class that implements an interface where we want to possibly check that certain events that are raised are going to be handled, possibly verify the order of operations that are being called by our system under test. That's called demarcated operations. And it's also useful for recording data that's passed from the system under test. So as you see here, we might have a spy logger, and that implements the interface. And then here, whenever the log message is called, we're going to be setting the value of the message being passed into the property message. Now, mocks are, the terminology for a mock here is similar to a spy, but it lets us specify some additional operations that we can check for expected outcomes, for example. The terminology here in Microsoft Test, we don't typically use the terminology for mocking with the word mocks, but there are other frameworks where they heavily utilize this terminology. Shims is something that represent a rerouting mechanism from the call associated with the production target to a test delegate, and a test delegate can be a simple pure delegate, or it can be a class that delegates operations. So this is useful if you're calling a method that is inaccessible, like a black box, for example, or a system-provided library. Here's an example here where this is right out of the Microsoft documentation for Shims, where we want to specify an override to the now property associated with datetime. So the datetime.now would return the current datetime, and one of the things we never want to do is change the system time for testing purposes. So this lets us create a bypass, so that whenever datetime.now is referred to in your test, it will return the value that you want it to return, as opposed to the actual datetime. And we set up what's called a Shims context, because once you defer the method that will be called, it remains in effect for the life of the test. So we use a using statement here to provide a context where, when we leave the context, the default behavior of now will then be returned. So where do these test doubles come from? Well, first of all, we can create our own. So you don't have to rely on frameworks. In fact, the way I started testing was to create my own. In other words, I programmed to abstractions. And it turns out that there's a bit more work involved if you don't use a testing framework, because the testing framework set up the underlying structure for you. But if you want to use a testing framework, there are some that are available that are better than others. Some are more complicated than others. And it's basically up to you to determine which is the best approach. You can mix and match. You can create your own test doubles, set up your own mocks, and so forth. And in addition to that, you can, in certain parts of your test, you can utilize the testing framework. So there, as I mentioned, there are different mocking frameworks that are available out there. Rhino mock, mock, NMock, and so forth. I found that MOQ and NMOQ are fairly easy and yet powerful, but my preference is actually Microsoft fakes, and unfortunately it requires Visual Studio Premium or Ultimate Edition. But I will be using Microsoft fakes in this demo, but it is not something that you have to use in your testing. I'm going to show you the technique. Okay, they all do a similar job. When you learn one, that knowledge usually transfers to others. Okay, so again, this is the goal here is to code to abstraction, and that makes our testing easier. Now I'm going to be copying the link to the demo again. For those of you who are just attending, I put on the chat window the link to this PDF, as well as the demo code that we'll be reviewing shortly. And the demo code is written in Visual Studio. And let me go through this. So I have a solution with several projects, and we're going to be testing what I refer to as an inventory service here. So we're looking at the class diagram for the inventory service. So you see that we have several methods, and we also have an overloaded constructor. Now the overloaded constructor, you see, takes in as an argument a type called data access, and you also see that our inventory service has an association with data access type. We'll be reviewing that shortly at a high level. And I also have an inventory service interface just to show you the contract. You'll notice that I have two events that are part of the service interface and also two methods, and all of which have been stubbed out in this example, and along with an out-of-stock exception that we're going to test against in the test that we'll be looking at. We have, as I said, another project that contains what we'll call our data access library. And this data access library is designed if we were to actually implement the data access library in a real production environment. This would talk to a database. I'm using entity framework in here, so it actually talks to the Northwind database. You're not dependent on this for this demo. However, if you want to take the sample and extend it to build a client application after you've tested, then feel free. So under solution items here, I have a README file, and this tells you where you can get the Northwind database. I'm using SQL Express on my machine, so you'd have to go into the configuration file and change the data source to your instance name. Most people use either LocalDB or SQL Express for testing purposes. So our data access class is what will be used by the inventory system that we'll be testing. So in other words, all of the calls would, in the real world, go to this data access instance and call into whatever methods I'm providing. And the methods that I'm providing are associated with interfaces, as you see here. I have a category repository, a product repository, and a unit of work interface. And these, notice, are interfaces, which means that we can set up test doubles. So when we make calls into our data access instance, instead of going out to the actual database, they're going to perform operations that will look for data inside of our test. That's the ultimate goal. You'll also notice that my data access has an overloaded constructor, and we pass in instances of doubles in the overloaded argument here, constructor. I have an I unit of work, an I category repository, and an I product repository. So this is very important when you're doing any type of testing, whether it be test-driven development, white box testing, or white box testing with combined with test-driven development. There are several different scenarios that you can go through. So let's go ahead and close this out, and we'll walk into the actual coding now. So we're going to look at the inventory services that I created. You'll notice that this is simply a stubbed out class that contains methods that throw exceptions because they have not yet been written. Okay, so when we're working with test-driven development, our objective is to write the tests first, then implement the code, because the first time that you test, if you leave not implemented exception in there, the test will fail. Then you go back and write the code. So we're going to implement the actual logic that will be associated with this class inside of in other words, we'll have to describe what is required by our system under test by writing the implementation inside of our test. So the goal would be to cyclically continue in that process until the test passes. And we're going to have several methods that we'll need to implement. So to make this just a little bit quicker, since we only have approximately an hour, I have here inside of the library, inside of the class library called Demo Unit Test Project. I have a file called Inventory Test, and I've set this up with some upfront terminology that we went over in the slides, just for your review, and also a link to documentation. I found it fairly difficult to find the documentation for this particular topic doing a search using either Bing or Google. It really took me a while to find it. But this is, let me go ahead and bring this up for you. Control click here. And so this is the documentation of writing unit tests for the .NET framework with Microsoft Unit Test. And notice that they have different versions that you can choose. They give you 2012 and 2015. But this is definitely well worth your time to go through this after we go through the webinar. So the first thing that you'll see here is that I have a test class. So we start out with a test class that's going to be testing some system under test. And I set up some default information for us for backing fields. It's just a class. We annotate it with test class. And so I have, notice here, a list of products and a list of categories. But you'll also notice that I have, I've given the products and categories names that correspond to the actual types. All right, but we're going to be creating lists of test doubles for these. In other words, as I said before, we're not going to want to go out to the database to get product instances. Instead, we're going to have to create what are called doubles for these. And I'm going to create an instance of both the data access class and the inventory service. So we'll be testing the real data provider and the real inventory service. The only difference is that we'll be going through our test doubles for accessing the actual data. So the first thing that you need to do, I put several comments in here, so if you want to go through and do this on your own, after the fact, it should be fairly straightforward. So I put a note in here that we have to add some stubs for category repository, product repository, and unit of work, because those are going to be needed. So the first thing that we're going to do is set up some backing fields. But you might ask, well, how do I go about doing that? Well, there are two ways. Number one, I could create a class. You probably normally create it in a separate file, but I can create a class here, and this would be my my stub product repository, for example. And this is going to implement an interface. So, for example, I might want to implement the iProduct repository. So if I were rolling my own without a framework, this is how I would do it. And because I have an interface, it describes the requirements of the product repository. So just click on Implement, and you'll notice this is very similar to my inventory system in that all of the methods are upfront stubbed out with not implemented exception. So if I wanted to create a double for my product repository, all I would have to do is write some code in here so that when the get products method is called by the inventory service, it will return a set of products. So instead of doing this myself, okay, because I'm lazy, I'm going to take advantage of one of the features in Visual Studio Premium or Ultimate, which are referred to as fakes. So if you'll notice I've already implemented this for you, because I know that not all of you will have Visual Studio Premium or Ultimate, so I want to provide you the library that will have the necessary libraries. So if you notice, if you right mouse button click on a library, any one of them, domain objects, whatever, there's an option here for add fakes assembly. Now I've already added this for my data library, and I'm going to double click on that, and this brings up for us the object browser, and you'll see that inside here we have what are called Shims and Stubs. So we talked about the Stubs and we talked about the Shims. Very rarely will you need to use Shims, but I actually came up with an example where we'll be able to demonstrate a Shim. Okay, but it's the Stubs that that most people use, and they provide you with the ability to create the methods that are provided by the system under test. And then the naming is a bit different. So like, for example, get product takes as an argument an int, and so the name that they give you is get product int 32. Get products takes no arguments. Get products by category takes one argument. Update product takes one argument of type product. So that's the approach that we follow. So we're going to be using, like I said, the fakes library. So I'm just going to set up some backing fields here. The first one we'll set up is the stub for the iProduct repository. So the name that they give you is based off of the interface, and the interface being I, it makes you think that it's actually an interface that you're creating, but it's not. It's going to be an instance-based or a concrete representation of a type. So we'll call it _stub product repository. And we'll do the same thing for our, semicolon here. We'll do the same thing for our category repository and our unit of work. Oh, what's wrong with me? I keep forgetting the semicolon there. Okay, and then we do the stub unit of work. And we'll call this _, I don't know, stub UOW. Okay, we typically refer to it as stub UOW. And what else do we need? So I have my data access, I have my inventory service, and it looks like we have everything we need. So one of the attributes that they give us in MsTest is test initialize. So test initialize represents a method that gets called before every test method. So this can be useful for setting up your test doubles and any particular settings that might need to be repeated before each test. And I find this to be very useful. Otherwise, if you don't follow this approach, you end up with bloated methods. So I first set up my categories, and then I set up my products. So you'll notice that when I set up my categories, I'm actually making up my own category instance. This is what is actually being used by the real data access library, but I make up my own. So think of it as creating your own test bed. When you're testing, you never want to go out to an actual database. Not that you're going to get, hit over the head for doing that. Some people do actually use real databases or live files, but the recommended practice is to either use something like an Excel file, or I think an even better practice is create small test beds directly in code, as you see I'm doing in here. So I want you to make note that I know what my categories are, and I know what my products are. So when I test, I can check expectations. For example, I have one of my products. I know what a unit price is. I know units in stock. I have another one that has a unit price but no units in stock. I know for a fact, based on the definition of my types, that if I don't specify units in stock, it'll be null, and so forth. So these are the things that you need to know when you're testing. I know here that I have 2 products in category 1, and I have 3 products in category 1, right? And I have 2 products in category 2. So I have a very small test bed that I have to work with here. So the next thing we're going to do is, and I have my comments, like I said, we're just going to create all of the infrastructure that we'll be needing. So the first thing, we have our stub category, stub product, and all that stuff. I'm going to create in here instances of my product repository. So you'll notice that there are no constructor arguments. However, my stub product repository gives me 2 properties that might be of interest. I'm sorry, 2 properties that might be of interest. There's instance behavior being one, and instance behavior lets us specify how we want the particular operation to perform. Okay, and another one being the up top here. This is the method. There are 2 methods that are of interest: behave as default value or behave as not implemented. Now remember, when I created the implementation directly off of the interface, all of the methods were designed to throw a not implemented exception. That's what would happen if I use this, which means that we're responsible for creating the actual method implementation. Behave as default value is a simpler case. It just basically says treat the method that returns like an integer, for example, as returning 0, or act as a default implementation with no arguments being passed in and so forth. You can use either approach. I like to use behave as not implemented. That way, if I am expected to call something and I don't, it won't just fall through with a no-op. And that's totally up to you as to how you want to do it. So the next one we're going to do here is stub category repository, and do the same thing here. The new stub category repository. And we'll do this. As before, we'll set behavior as not implemented. And we'll do the same for our unit of work. And here we say behave as not implemented. To me, it's just a safeguard. I've seen cases where people just use the default, but either way works. Now the real piece that we're of interest here is recall that we have a real inventory service and a real data provider that I set up as being associated with the actual type that we want to test. So our real data provider, for example, is what will be called from the inventory system. So I'm going to create a new instance of this. Data access. And data access, as I showed you earlier, is overloaded. The default constructor literally is designed to go out to the database. In other words, the default argument is implemented in a way that it is dependent on. It's an internal dependency on entity framework, which then goes out to the database. But we're going to use the overload. So the overload lets me pass in instances that represent a unit of work. So the unit of work, by the way, if you're not familiar with that, it's basically something that persists, like a method called save, or save changes is what we use in the entity framework. There's a save changes method that's associated with the database context. We're going to use our own save mechanism. It doesn't matter what we do. So I'm going to pass in as an argument here the stub UOW. Now this, when we pass in stub UOW, this automatically will implement the interface, so we don't have to cast anything back. It just works. Makes it very easy to use. And the second argument will be our category repository. And the third, I believe, is the product repository. Okay, and then a semicolon at the end. That should be adequate. And lastly here, we'll do our real inventory service. And the real inventory service is going to be, as before, just something that works with the data access layer. And the data access layer, as we just built, is called the real data provider. Okay, see how the pieces now fit together. So the first thing that we're going to do, I put a bunch of comments in here for your sake and for mine. I don't want to forget anything, right? I need my own notes. Okay, as with any instructor, I did my own little dry run of this morning. So I'm going to notice over here I have Test Explorer. So if you go to Test, they give you Windows, and then they show you Test Explorer. That's this window here. And if I click Run All at this point, I haven't implemented any of the code, so I have a bunch of assert inconclusive methods that I'm calling, which means I haven't gotten around yet to filling in those blanks. So when we run the test, down at the bottom here in our output window, it will tell us that it's going through and it's running the test, and when it completes, it'll give us an outcome. So we should see the same outcome for all. I'm not going to explain what this is saying, but basically these are inconclusive. They think of it as neither pass nor fail. We never really did anything, so it's not an error. So we need to now fill in the gaps. So the first one here is I have a method in my inventory system. So let me go back to the inventory system and just to refresh your memory. So I have a couple of methods in here. Notice how short and sweet this is, and it's going to take us, an hour. So this here, we have a purchase product and account products in the category. So we're going to first start by doing the count products in category. And so I know that the first thing I'm going to need to do is create something that represents a counter. So I'll call it count here. And the next thing that we're going to do is go into the real inventory service and get the value for our count. And then I'm going to check or verify that it meets my expectations. So we're going to call into the real inventory system the method called count products in category. There you go. And it needs you to pass in a category ID, and we'll just pick like 1 here. But there's a problem. What will it call? Well, remember the underlying methods are stubbed out with not implemented. So if I were to test this right now, it would throw an exception. So we have to have some way in which we can actually implement the method behind count products in category. So that's what I'm going to show you how to do. So the first thing I want to do is go back. We're going to be talking to my product repository. So if I go to my stub product repository, I'm going to look at the method called get products by category that I wrote. And this is going to give us the implementation details. And we're going to be using a lambda expression or a lambda argument to specify what this looks like. So get products by category is going to take as an argument an int32, and it's going to return a value that corresponds to the I'm sorry, get products by category int32 takes as an argument an int32, and it's going to return something that represents a collection. So let's pass this in. Okay, so we're going to do this. Excuse me, get this right. So we're going to set up a lambda expression. So we're going to pass in an ID. Oops, let's see. ID, escape, and we're going to implement here the code that we want to execute. So you might find this to be a bit troubling, so if you're not comfortable with lambda arguments, you might want to consider just rolling your own. But I'll show you how this works. So what this says is we're going to be passed in an ID. When this gets called, we're going to be passed in an ID. And what I need to do is call into the real products, or the products list. And the products list has a where method, right? It implements IEnumerable. And this is going to take in a product, which we'll call P. And given that product, we have to tell it what to expect to be true and what to expect to be false. So I want to make sure that it's going to return the set where the category ID matches, where the category ID matches the argument being passed in. That should do it for us. And now, when I call count products in category, it'll call into this method here, and this will go through my repository. So that should return a list of all of the products that are in category 1, and I believe that there should be 3 of them. Okay, so let's go ahead and build an assertion now. So we have everything that we need. I'm going to say here assert dot, and you have the arguments that you can pass in here, or the methods that you can pass in, are several. And so I'm going to say R equal, and R equal will be expected and the actual. So the expected number will be 3 because I have 3 in product category 2 and category 1, and the actual will be whatever count came back. So, and that's it. So again, this is my assertion is based on going to product category ID 1, where I have 3. So there should be 3 products in that category. Now the first thing that you'll do is test this, and right mouse button click on the method name, and you can choose run tests. So this is going to fail the first time, and which means that we have to then go in and write the actual code. So I just want to show you what happens when it actually does fail. Okay, so it throws an exception to fail. So we're going to go back into the count products by category, and we'll write the code. And this time I'm going to make it hopefully pass. So I'll do the same thing I did before. We'll create a count variable, and just write some simple code in here. Okay, so we'll say something like from P in data access, and this has a property that I created called iProductRepository. So I'm going to call into the product repository method called getProductsByCategory. And the category that I'll pass in, I'm just going to call this here ID, and pass in ID here. All right, now we're not quite done. We're now going to say select P, and then get the count from here. So the method called count, and now I can say return count. That should do it. So if I go back to my test, by the way, one thing I should mention is that you can actually step in with the debugger for testing as well. One of the options they give you here is debug tests. I'm just going to cross my fingers and go for broke. I'm going to say run test. And this should be satisfactory. And if it doesn't work, we just walk through with the debugger. Okay, so it passed. And notice it gave me the number of milliseconds. So let's move on to another one. Now we're going to run these tests not to do any more than what we expect the test to accomplish. So like this next one here, I'm saying when we call the purchase product method, when a product is in stock, I want the units in stock to be decremented. That's what I want to test against. So the goal would be to set up our infrastructure. I gave my notes here. So we're going to set up our infrastructure again that goes into the products by category. And that'll save me some time copying and pasting. And after we do that, we're going to call into the method for getting the product by that integer identifier. So our stub product repository has a method called getProductIn32, and so I'm not going to, let's see, I copied the wrong one, I guess. Okay, I don't need to do this in this case. So I guess I'll have to start from scratch. So we're going to say underscore stub product repository, and we'll have to do the get product call in this one. Makes it more understandable. So this would be get products. Okay, the one we want is get product in 32. Okay, so because we're going to purchase a product, and I need when I call it, I'm going to get back a product and check the units in stock, and then I'm going to call the method for decrementing the unit price, and then test to make sure that the values are the same as expected. So let's go ahead and do that now. We're going to pass in here for this another lambda expression, and this one here will pass in some n, we'll call it, doesn't matter, and that's going to take in an argument. And just to follow along here, since we'll be doing another lambda, I'll just type in return, and this is going to go back into the real products. And so I think we call that products. Right, so the products has a method that we can call as a link method called single, and we're going to pass in here the product that matches that ID. So the single, we can use single on default, however you want to do it, and this will be taking that number n and verifying it against the product ID. So my lambda expression will take a p for product and compare the product ID of that with the value n that's passed in, and that should do it. So again, just setting up your stubs is the main chore or the main task. And after you do that, we can now call into the method. So we'll say here product, and we'll call into our stub product repository and call that method get product. And like before, we'll pass in a number 1, for example. Okay, it might be better practice to set that up as an argument so you don't make mistakes, but you know how that works. So we'll create var here and units before and units after. And that would be units in stock. And now we're going to call the method for purchasing the product. And that goes from our real system. So we go into the real inventory system. And we call purchase product. And pass in an ID, and again the ID will make sure we have the same as before, or you can just do product.product ID, it doesn't matter. That should be a 1, obviously. And the units after will be available from our product. So that we product units in stock. So now we have to do another assert. And this time we'll say you have a number of different choices. As you go through the list here, you see you have a number of different choices. I think we're just going to use is true. And I'll show you how that one would work. I'll say I want to make sure that the units before, or the units after, maybe, plus 1, because it's been decremented, is equal to the units before. In other words, I want to guarantee that it's been decremented. And recall that before I go any further, that the product whose ID is 1, I'll scroll up here, does have a valid number for units in stock. Okay, so if I were to pass in a 2 there, it would fail because I have no units in stock. So again, if you know that if I ran the test at this point, it would fail because it's not implemented. So if you were to be a test-driven developer, you would run the test at this point, know that it failed. I'm going to, just to save some time, I'm going to go ahead and write the code that I expect will work. So we're going to look at the purchase product, and all I want to do is implement just enough to make that test pass. So our purchase product is going to go out and grab a product. That's the beauty of this. You just have to write enough code so that it passes, and then you write other tests for looking further into the system. So this is going to go into the iProduct repository, and I'm going to call into the method called getProduct, and pass in some ID. Let's make that lowercase. And after we get our product, we're going to decrement the units in stock. That's all we were told to do. So it would be, I'll wrap this up, p.units in stock. Okay, that way it jumps out at you what it's doing. And now in the real world, if I were to continue on with this, there would be a little bit more in purchasing the product. At some point, I want to call commit changes. I might want to have it persist or whatever the case might be. But I'm not going to be doing that. All I was told to do is to just make sure that this is going to pass. So let's go ahead and test this out. Hopefully, it will work. So we're going to go ahead and run the test. Then the reason it takes a little bit of time here is because it needs to do upfront setup for the test environment. Okay, and it looks like that passed as well. In fact, if we run all, it should pass both of those tests. So we're going to go on after we're assured that they both are still in working order. We'll move on to the next, which is when we want to actually test to see that I'll have to check to see what the method is. I forget. It's yeah, okay. When called with product, okay. When called with product in stock, that the product is going to be updated. All right, so let's go ahead and implement that. So our goal here is, it looks like in this case here, I can just copy and paste this piece of code in here. Okay, that's going to grab a product in stock. We know that that is in stock. And that will, again, that will be assured each time because before we have the test initialize. So after we set that up, we're going to call the method called update product. That's part of my product repository. So let's go ahead and do that. So I have to tell it what the behavior is of the update product. So underscore stub product repository dot update product. Update product takes an argument in. So it says action of product, which means we pass in one argument and it returns void, update product. So that will look something like this, is equal to P, and then write the code here. We'll figure out what it's going to do in a minute. And now we can call into that method for getting the product. So product. So we go back to our stub product repository, and we're going to call the method that it's called update product. And again, pass in the product ID. This should be a 1. Make sure that you pass in the right numbers. I've made that mistake before. I'm sorry, wrong one. That's not the call I wanted. It's get product. I'm not sure how that happened. I'm not paying attention. Get product in 32. There you go. And that should work. Returns a product. And let's already defined in this scope. That's why I was getting myself confused. I already had defined this. Okay. And we'll pass in a 1 here, I guess. Okay. And let's see, I want to make sure I'm doing this all correctly. We're making a call to get the product. And once we get the product back, I can now call into my real inventory service. Okay. This should look good. And now I can call purchase product. And purchase product is going to take that product ID. Okay. But now, what do I have to do? How do I know that it's actually been called? So here's where that mechanism that I talked about before called spies come into play. Writing a spy can be a bit of work. I actually have one that we're going to look at later on, but I'm going to create what I'll call an inline spy, which means I want to guarantee that this method is actually going to, when it gets called, I want to know that it gets called. That's my goal, all right? I want to know that the updated method is called. So I'm going to set up here a little flag. I'll call it updated. And I'm going to set that to false. So when this method in the system under test does get called, I'm going to verify it, verify this outcome by setting this to true. So this is what I want to check. I want to make sure that this method is called, that the updated method gets called. So I just have to say here, assert dot is true, and we're going to pass in the condition, which is updated. Easy enough. Okay, so the next thing that we're going to do is look at the code that we would have to write in here. So this means that at this point I need to go back to my purchase product, and I'm going to have to do something that causes it to call update product. Well, we do that after the test is done here, after we decrement. So we go back into our data access layer and through the iProduct repository, and we call into update product and pass in the product P. Now recall that we still have other tests that are using this particular method, but as long as I did this correctly, all should be copacetic. I might want to mention that there are a couple of ways that we can implement this. Purchase product can call directly into commit changes, where we'll write some code to commit changes, or it can be designed as a system where the methods are actually decoupled or not directly intertwined. So the first thing our user would do is like click a button on a web page, and that button would purchase the product, and then they would click, save changes, or go to the next page where we commit the order, and that would call commit changes. So that might be a better approach here for testing. So let's go ahead and run this. Let me just take another check because I got a little stumbled while I was going through this. Update product is true, call get product, purchase product. Okay, it looks good. And we're going to go ahead and run this test. So we might go a little bit beyond the 3 o'clock deadline. And if it takes too much time, I'm going to upload the final solution when I'm done. So don't be too concerned. So that worked very good. So it looks like we're getting someplace. We're getting someplace. This all passed. Now again, run all to make sure that we didn't break anything in the other methods that are also being called. And I think that we're okay. Okay. So this one here looks like it failed. Units in stock decremented. And that was the one that was working before. Okay. And let's see what's happened there. So there's something that's not implemented in the units in stock. Okay. Okay. So what we need to do then is looking for this method here. Okay. Because I set these up as throw an exception when not implemented. So we can easily fix that. What I'm going to do is I'm going to just stub the call out. In other words, I don't care what happens. I just want to make sure that gets called, because by default it throws an exception. You notice that it ran successfully on the individual test, but not when we ran all. So let's go ahead and run it again. So that says call update, when update product gets called by the system under test, that we wanted to just make sure that the call is being made, and that's all, just to pass the test. There you go. So again, even though this is doing nothing, that's okay, because our goal here is just checking the units in stock. But because we specified the default behavior would be throw an exception for any method that we didn't explicitly implement, right? So that meant that at this point, when we called the purchase product, it was trying to call this method, but it hadn't been implemented in our previous test. So that's the reason for that fail. And you see how we're building now a system where we're guaranteed that things are going to behave as expected even when we start making changes. So the last one here, or the next one, says that when we call commit, I'm sorry, up here, when purchase product is called, when a product isn't in stock, we're going to throw an out of stock exception. So it turns out that what we can take advantage of here is another attribute that's given to us that's called expected exception. And the type of exception that we're going to be looking for is an out of stock exception that I've already implemented for us. Okay, so we're going to throw an out of stock exception. So that means I expect when this method gets tested that it will throw an out of stock exception. Okay, if it doesn't, that means that my test is wrong. So this would be out of stock exception. Okay, and so let's go ahead and write the code for this. So I guess we can copy and paste again. I'm getting good at that. So we're going to call this method again. Set up our method invocation. And we're going to call back into this right here. Get product. But this time, okay, when the product is not in stock, it's going to throw an exception. So 1 is in stock. 2 is not in stock. Let's verify that. Save us some time from having to go through it again. So 2, so if it's not set, then units in stock is null. But I'm just going to, to make sure that you see that, I'm going to set it to 0. All right, so it makes it a little easier to see. Okay, we'll come back down here now and get this piece finished. And it looks like the only thing we need to do now is call into the real inventory system and call purchase product again and pass in the product. This is really nice. Okay. Okay. Real inventory dot purchase product. Oh, I need to pass in the ID. Sorry. There you go. All right, so I bet you at this point you can see that it's going to fail when I run this test because I'm not throwing an exception. So we hope that this doesn't work, right? If it does work, we have a problem. So it's running the test. And that should fail. Okay, good. So we're going to go back into our inventory service here, and now we're going to modify this code. So when we grab our product, I'll say here if the product has a value, then we're okay. So if p dot has value, so product units in stock dot has value, that means that we're okay. But if it doesn't have a value, we have a problem. It means it's null. So if it doesn't have a value, or the next thing we want to test against is whether the units in stock is 0. Okay, so it'll be p dot units in stock is equal to 0. Then we're going to throw the exception. Throw new out of stock exception. Okay. Now notice update product again is here, but I don't need to test for that because assuming that this works, so I don't need to set up the stub for calling that method because once you throw an exception, this code never gets executed. So that should be enough for our test. Let's go ahead and run this. So assuming that it throws the out of stock exception, we should be fine. And it's still running the test. And it worked. Okay, let's look at another one. So it's almost 3 o'clock, but we're okay. All right, so let's see. We're going to move on to the, we're going to come back to the SPY. I want to show you how to use a shim, just in case you had a 3 o'clock deadline. I know that we're getting late here. So we're going to look at a shim now. And so my goal here, it says when dispose is called, I want to make sure that the data provider is also disposed. So in other words, let me show you what I want to do. I'll save some time here. So my inventory service implements inventory service, and my inventory service implements disposable. So that means that I have a dispose method here that's going to be called. That's assured. But, so again, I'm going to get rid of this. I want to make sure that the following is true, that the data access layer, which is the piece that actually goes out to do what it needs to do to the real database, right, that dispose method gets called. Okay, I want to be assured that that is the case. Okay, so in order to do so, I'm talking directly, in this case here, to the method that's associated with my data access provider, but that's really off limits to me. So it's kind of a black box at this point. So I'm going to fudge the behavior behind that particular call. In other words, when it calls that method, I'm going to have it do something else, similar to what we did with our SPY. And we're going to use a shim for that. So we set up our shim, if you recall, using a using, and the using uses the shim's context. And there's a method here called create. This way here, once we reach the terminating brace, the context is released, and anything that we deroute or that we reroute will be put back to its original implementation. So let's go ahead and set up a flag here. I'm going to say data provider, whoops, dispose called, and set that to false. And now we're going to create an instance of this shim. So this is of type called shim data access. That's given to us by Microsoft Fakes when we created our fake. Shim data access. So it creates its own name. I'll call this shim DA is equal to, and we create a new instance of our shim data access. And we're going to pass in as an argument to this method the data access instance. So remember, that's our real data provider. So it's going to go directly to that data provider. And now we write the code that we want to be executed for our dispose method. And that's going to be a lambda expression that's associated with an action. And all I want to do in here is set the data provider dispose called flag to be true. And if you walk this through, it's interesting, if you walk it through with the debugger, you'll actually see that it goes into the real data access provider and does its thing. So here we're going to say assert, as before, dot is true, and pass in the data provider called. We want to make sure that that actually gets called. Okay, so that should do it. And we're going to go back to our inventory service test. And so I've already implemented this. Again, I'm, for the sake of time, kind of stepping this through quickly. So let's go ahead and run this test. And we have one more method to call, to write, so we're going to be probably 15 to 20 minutes more. But I think you might find it interesting if we actually stepped into the code. So let's assume that this works. Okay. And it didn't. Okay. So let's go ahead and fix this. Suppose. So this is going through my data access dispose and my inventory test. Let's see what I did wrong. So we created our, that's false, create my shim data access, set up my shim dispose. Oh, geez, I see what I did wrong. All right, good. Think about what's missing here. I just went back to look at my real inventory system. Well, I never called the real inventory system. So I have to call its dispose. Okay. So sometimes building your tests can be, quite a bit of work, but in the long run, it's going to save you a great deal of time and headaches, particularly maintenance and regression testing and so forth. So the test is running again. And it worked this time. Okay, good. So let's go ahead and set a breakpoint here. Just want to show you what happens. You might find this interesting. And I'm going to choose debug tests. So this time it has to takes a little bit longer because it has to load up some symbols. But after it does, so it should set a breakpoint for us as it's running directly in the code there. There we go. All right. So I'm going to step into, that's F11. Okay. And so now we're back here in the inventory system. Okay. Sets up my context and see what happened. So it's basically saying reroute it. That's our goal. Reroute the instruction. So we are basically saying replace the method that would actually have been found in the data access layer with our own implementation. And lastly, we want to talk about this thing called spies. And so we've been using the inline spy, a couple of different approaches there with setting up my flags, but you can actually create your own class that holds methods and properties that you can then check for, as I said before, making sure that things are called in an appropriate order, making sure that events that are being raised are handled, and the like. So here's my goal, and again, for the sake of time, here's my objective. Let's assume that as part of our specification, all right, this is what we want to happen. When commit changes is called, we're going to note that I have here two event handlers. Okay, that I'm just this is a null pattern. So when commit changes gets called, I'm going to raise an event called onSaving. Okay, I don't need to check to see if there are any listeners because I'm using that special null pattern, by the way, and that's going to be this. And that's going to be event.args.empty. Now I'm going to call into the actual data access dot save changes method, whatever that does. Now that's associated with the unit of work, which means it's going to call into a method called save. And when I'm done, I want it in this order, by the way. This is the order that it has that I want to be assured that it doesn't call on saved before it actually saves and so forth. Right, so again, this and then event.args.empty. So again, this is my goal, and I'm just shortcutting it for us because we've run over a little bit. So what I did here, notice that I have a constructor, and I'm going to pass in my inventory service. This is going to be the test double. And because I need to provide a way in which I call into the unit of work, which calls save, which is the effective save persistence of any changes, I'm going to pass in the stub unit of work. But recall that I have not implemented any of the underlying methods in the stub unit of work, so I need to provide an implementation inside of this class. So I just hook up event listeners inside of this class, and then I set the value of the save method to be this method here called onSave. And here I just say, onSaving is true or whatever. So I do that in all of the cases. So in other words, I provide my own implementation for these particular sets of methods. But because I want them to be guaranteed to execute in an exact order, I'm going to set up some flags, saving, save changes, and on saving, on saved. It would have been, it's by default anyway, it wouldn't have mattered. But let's do it the right way. Sorry about that. Just happened to catch that. So when this works, you can probably follow through the logic here. So I expect this to be called first, right? And then onSave to be called second, and then onSave to be called last. So when onSave gets called, I check to see if the value of onSaving is true. And if it's not true, I throw an exception called demarcation exception, which I just built down here. Now that's not part of my system under test. That's part of my test environment. Okay. In other words, I want my test to fail if that's the case. And I do the same thing here for onSaved. I want to make sure that onSave changes has been called, right? Or whatever the method is. Right? OnSave changes, whatever the property is. So the same logic is going on in here. And it has to occur in that order. So what we're going to do then, and this isn't actually very complex at all, the first thing we need to do is we'll remove this line of code here, and we'll create an instance of our spy. Spy persist, and we'll call it spy. So again, remember the terminology I was talking about? It's just a small nomenclature change, and you can call everything. You can say everything is a mock. It really doesn't matter. So don't get bogged down to the terminology. So we'll create a new instance of my spy persist, and we're going to pass in here the real inventory double, followed by my stub unit of work, as I mentioned before. And now we're going to set the method for update product, because we're going to need that. It's going to call into that. So remember, we needed to set that up, otherwise it fails. So we'll just set this up as a dummy call. Where was that we did it? Somewhere. Yeah, right here. Copy and paste again. I happen to know that will fail because it's going to be expecting that. Okay, so we do nothing. Just set up a no operation, and you can set that up in the test initializers as well. There's nothing that's stopping you from doing that. Okay. Trying to think. Do we actually need that? Do we need that? No, actually, we don't. Do we? No. That doesn't hurt anything. Yeah, no, we don't need it. I'll leave it there, but no, I'm just thinking we don't need that call. So let's go ahead and call into our real service and call commit changes. That's it. And now our assert. Okay. Now I'll assume that everything went in order, but again, I want to make sure that the methods were actually called, right? All I'm checking for is for the demarcation is the value. So I want to make sure that they were called in the right order, that they were called, and that they were called in the right order. So we're going to say is true, and then we go back to our spy and say that onSave was called, and spy dot onSave changes were called, and again the order here is irrelevant. If as soon as one of them is false, they're all false, right? Whatever follows is false. And this would be onSaving. Yeah. Again, the order here is irrelevant. So, yeah, let me comment that out. Like I said, we don't need that there. It's my paranoia. So let's go ahead and run this test, and we should be all set. So what I'll do, because we shortcutted, right? I'm going to, assuming this works, we'll go back, and it'll take us a minute to just break the demarcation. I'll not call something that was expected to be called, and see that it breaks. And it passed. Okay. So just to show you, let's comment this out. Right. So we'll just do the 1. Let's make sure that it's still that it's going to fail this time. Run the test. Yeah, you look down at the bottom here. Notice it hasn't finished yet. So this should fail. There we go. Good, good. And one more. Let's put them in reverse order, or just put them in some other order. Right. Remember, I said we want to check the demarcation, the order in which they're being called. Run it again. And again, it should fail. So, assuming that this works, in other words, that it actually does fail, I'll put it back as it should be, and we'll then do one final run of all of the tests. Okay, so it does fail as I expected. All right, so let's put this back in the original order, which would be on saved and then on saving. That's pretty cool, huh? Yeah. And I'll run all this time. And cross my fingers that it didn't break anything else. So again, we want to make sure that all of them are successful, that one change didn't impact another test. So, and I'll also upload this final. There you go, success, applause. All right, good, good, good. All right, so I'm going to, after this session is over, I'm going to upload the final version here to our server. And I'm going to also copy, for those of you who may have come in very late, I'm going to upload to the chat window the link to this demo and to the slides. Other than that, we are finished with the demo. Thank you so much for your time. I hope you enjoyed.